Assalamualaikum and good afternoon to our beloved lecturer and to our students. So for our group today, we will present to you about the drying operation for agriculture and forestry products. So our team consists of 5 students, which are me, myself, Muhammad Izzat Syahmi, Muhammad Syamil bin Azmin, Muhammad Syamil Sadiq, Muhammad Amir Faisal and Daniel Haziq. So we will move on to the introduction part. So what is drying? Drying is the process of the removal of water or moisture from hygroscopic materials. So what is a hygroscopic material? It is a substance or material that are tending to absorb moisture from the air. So any material or object that can absorb air, that can absorb moisture from the air, is called hygroscopic. At low to medium moisture content, normally below 30% water basis, the drying operation will be evaporation. But when the moisture content of the agriculture product is high, usually above 50% wet basis, the process of removal of moisture is referred to as dehydration. So the example of the product that are dried include cereals, oil seeds, legumes, and some processed food. And the example of product that are dehydrated include fruits, meats, and vegetable. So the main purpose of next is the objective. So the main purpose of agriculture drying is often to reduce field loss and weather damage and to maintain product quality during subsequent storage and delivery. This is in contrast to the drying of wood, whose main purpose is to have all the shrinkage and distortion take place before the wood is to put into us. The reduction of insect and fungal attack is another reason for the need for wood drying. Next, I will pass to the next presenter, which will present the method.
Okay, now I will explain about methodology. So basically, this drying operation involves of application of thermal energy. This thermal energy is achieved by heating up the product and also forcing hot air through it. Then circulation of air also happens that helps to carry the heat and the moisture away from the product in order to promote the heat and mass transfer. Then thermal drying is involved in water phase. It's very energy intensive activity. For example, like evaporating 1 cup of 250 milliliter of water require the same amount of energy as needed to heat a big pan of soup with 3 liter volume from 25 degree to 70 degrees Celsius. So the efficiency of energy in drying processes is significant in context of energy, economic, and also environmental policy goals. So it offers the advantages of better control over the product quality, and also higher productivity. So basically, most of the artificial dryers also use the direct heat and vent method to drive the drying process. I will pass to the next presenter.
Okay, so now I will explain about how drying takes place. So first of all, evaporation may take place in 2 stages. So for the first stage, there may be sufficient moisture within the product to replenish the moisture loss at the surface until the critical point is reached and a dried surface formed. Evaporation is then dependent upon the rate of internal moisture diffusion, and this process is also called the falling rate period or second period of drying, and is often a diffusion process. And then for the diffusion, is typically a slow process and is mainly controlled by internal moisture transport of the product. external mass transfer plays a relatively small role at this stage. And now for the second stage, as the product surface is dry, it is restrained by the wet core so that it is subjected to a tensile stress. As the core dries, it is in turn restrained by the drier surface so that the stress profile inverts. And at the end of drying, the product surface may be left with a residual compressive stress. The core is subjected to a tensile stress, and this is also called case hardening. And for the drying schedule, it will therefore need to ensure that the stress developed during any period of the drying process do not exceed the strength of the material so that the stress damage of the product doesn't take place. And at the end of drying, stress relief for the residual stress may also be carried out. This is very important when a product needs further processing or when a high temperature, fast drying schedule is employed. Cooling of agricultural products also minimizes the water condensation on the product surface. So now we will move on to the next part.
Okay, for these drying operations, the application of heat transfer related are conduction and convection. So I will explain about conduction. So conduction is heat transfer by means of molecular agitation within a material. So in this conduction process, no motion is involved, which means the material that is conducting heat will not move at all, except for the molecule, in the object. So, for example, if one end of a metal rod is at higher temperature, then the energy will then transfer down the road towards the colder end, which means if the rod is we will label it as left and right. So if the left side of the rod is at higher temperature, the energy, the heat will travel down the road to the right side of the rod. So in this process, higher speed particles will collide with slower speed particles, and then the energy is transferred. In other in other example, we can see when we are cooking in the kitchen using a pan, the pan will conduct heat from the fire from the stove. So that is also another application of conduction. So in the drying process, conduction happens between the fillet and the hot air in the plenum chamber. So for convection, I will pass to the next presenter.
Thank you to Daniel. So I will continue with convection. So the definition of convection is heat transfer by mass motion of a fluid. So there are two types of fluid which are air and water. So it is happened because of the heated fluid is caused to move away from the source of heat and carry the energy with it. So for example, convection above a hot surface occurs because of hot air expand and become less dense and also rise. So in this application of the drying process, the heater generates the electric current. So when the heater generates the electric, it transfers the electric into the coil. So the coil will become the electric become transfer into the heat energy. So as you can see the figure below, so the heater shows the transfer the electric to heat energy. It will become the air, the temperature of air is rising, and when it go to the cooler side, it will the cooler air will become warmer, and the the inside the chamber will become temperature will become equilibrium. So it will follow the ideal gas law for the constant pressure. So next.
Okay, for the conclusions, drying is a significant operation in the agricultural and forestry industries. A lot of research and development of drying technology are made to improve the product quality, reduce costs, and also to improve environmental performance. So a number of innovative methods and drying technologies are being developed to be applied in agricultural field. So the efficiency of and performance of different dryers varies significantly. Energy consumption is very strong, and the energy consumption is strongly influenced by the dryer design and also for the individual skill itself. So among them, drying with modified atmosphere and improvements in sensor and control technology have shown significant promise. That's all from us. Thank you everyone for watching.